List is an essential data type in Python, and in this tutorial we are going to learn the functionality of built-in list methods in Python. So make sure to watch this video till end. My name is Rishabh and let's get started with it. Number one, the append method. So this method adds an item to the end of the list. So let's say we have this list, and as you might be aware, that list can contain homogeneous data types. So we have an integer value, a float, a string, and a boolean. If I want to add an element to the end of the list, I'll write list.append 1000. So 1000 is the element that I want to add at the end. And now if we run this, we'll see that 1000 is added to the end of the list. And append is an in-place operations. Most of the built-in methods that we see for list are going to be in-place operations. We can also append an iterable to the list. So let's say we have a tuple looking like this, and we want to append this whole tuple to end of the list. So we write ls.append and given this tuple, and now if we run this, we will see that this tuple has been added as a whole to the end of the list. But what if we want to add the individual elements of an iterable, or in this case this tuple? For that we go to number 2.
What?
You said number 2.
The extend method. So the extend method of list takes an iterable and it extends the list by appending all the items from the iterable. So let's say we have a list looking like this, ranging from number 0 to 9, and I want to add the elements true and false to it. So I'll write list.extend and this iterable, and now if I run this, I'll see that true and false has been added as individual elements to the original list, and it works for any iterable. So since strings in Python are an iterable, and if I specify a string like this, then it's going to append each element of an iterable, and in this case each character of this string to the original list. So now if we run this, we will see that individual character of string are appended at the end. Number 3, the insert method. So the insert method takes two arguments, the index and the element x. So it basically inserts an element x at an index I, and this is also an in-place operation. So let's say I have a list of strings looking like this, and I want to insert the string sum at position 2 or at index 2. So I specify it like this, and now if I run this, I'll see that sum has been appended at index 2. If you want to add an element at the beginning of the list, you specify index 0, and if you want to add it to the end of the list like the append method, then you specify the index as the length of list. So now if we run this, we will see that A is appended to the start of the list and Python is appended to the end of the list. Number 4, the remove method. So the remove method deletes or removes the first occurrence of the element x from the list. So let's say we have a list looking like this, and if we specify list.remove 20, then it's going to delete the first occurrence of 20, that is up here, and this is also an in-place operation, so the original list would get changed. As you can see, the first occurrence of 20 has been removed and the second occurrence at index 2 has been retained. But the remove method raises an error when the element is not found in the list. So if we try to remove the element 100, then it's going to give us an error. Number 5, the pop method. So unlike the remove method, the pop method removes the element as well as returns it so that we can store it in a variable. So let's say I have a list looking like this, and I want to remove and store the element located at index 2. So in this case, it would be 30. If I run this statement and we print this, we can see that the element has been stored in the variable var and the original list has been changed to. Similarly, you can remove and store the first element from the list like this and the last element from the list like this. So if we run this, it's going to change the original list as well. So we removed 10 first and then we removed 50 up here. Number 6, the clear method. So the clear method, it removes all the items from the list, but it retains the variable or the empty list. So let's say I have a list looking like this and I run ls.clear, and if I print this, I'll see an empty list, hence all the elements have been removed. So the clear method is similar to this statement. To test it out, if I run this, I'll see that the output is same as the clear method. But if I want to delete the list from the memory itself, then I just need to write delete and the list name. And now if I try to print the list, then it's going to give us an error. Number 7, the index method. So the index method returns the index in the list of the first item whose value is equal to x. So let's say I have a list looking like this, and if I run this command ls.index20, then it's going to return the first index where value 20 is present. So if I run this, I'll see that it returns 2, which is this index up here. I can also specify the start index and the end index to search within a limited subsequence of the list. So let's say I just want to search within this space. I can run it like this and it's going to return the index not in this specific subsequence that I'm searching in, but from the starting of the list. So it returns index 5. So index 5 is 0, 1, 2, 3, 4 and 5. So this is the first occurrence of 20 in the subsequence that I'm searching in. Number 8, the count method. So the count method returns the number of times an element appears in the list. So let's say I have a list looking like this, and if I run list.count10, then it's going to return me the number of occurrences of the element 10. So it says 4. And the good thing, it doesn't error out when the item is not found. So when this element 0 is not found in the list, it returns that as the number of occurrences is 0. Number 9, the sort method. As the name suggests, the sort method of list sort the items of the list again in place. So let's say I have a list looking like this, and if I run list.sort, then it's going to sort the elements in ascending order. So if I run this, I'll see that the elements are sorted in the ascending order. I can also specify the argument reverse if I want the elements to be sorted in descending order. So if I specify it reverse is equal to 2, and now if I run this, I'll see that the elements are sorted in descending order. But this is where it gets all fun. So let's say I have a list looking like this, and I want to sort this list based on the length of individual element. So here I can specify the key on which I want the list to be sorted. So if I specify key is equal to len, then this len method is going to be applied on each of these individual elements, and the output that we get, that is going to get compared, and the list is going to be sorted accordingly. So now if I run this, I'll see that this original list has been sorted based on the length of individual element. So we have 1 element, 2, 5, and so on. And you can also provide some complex custom functions like this one. So here I'm going to sort the list based on the number of occurrence of the character I. And now if I run this, I'll see that it has been sorted accordingly. So 0 occurrence, 1 occurrence of I, 2 occurrence, and 3 occurrence. Number 10, the reverse method. So the reverse method reverses the given list in place. So let's say I have a list looking like this, and if I run ls.reverse, then it's going to reverse the elements. As you can see, the elements have been reversed. So the reverse method is not equal to the sort method, with reverse is equal to true flag. It does not sort the list into descending order. It just reverses the occurrence of individual elements. And number 11, we have the dot copy method. So the copy method of list returns a shallow copy of the list. There's a difference between deep copy and shallow copy. So shallow copy is basically copy by reference, and deep copy is copy by value. So let's say I have a list looking like this, and I copy the original list into another one. So if I print the new list, I'll see that the original list has been copied into this one. But since it's a shallow copy, so if I change any elements in either of those lists, then they are going to get affected in the other list as well. So let's say I update this element and change it to 100 in the original list. And now if we print the newer list, then we are going to see that the change has been reflected here as well, because they share the same reference, and the value at that reference has been altered. Another cool fact about shallow copy is that it is only the copy of top level elements. So if I change the elements like 10, 20, or 50, they are not going to get reflected in the newer list. So if I replace this element from 10 to 0 in the original list, then it's not going to affect elements in newer list. So now if we run this, we'll see that in list 2 we still have the element 10, whereas it has been updated as 0 in the original list. Alright, so that is it for this video. If you learned something, give it a little like and consider subscribing to the channel maybe. Thanks for watching the video, and I'll catch you guys in the next one. Bye bye.